So scatter plots and association. Um, so today we're going to learn what a scatter plot is and how the data on a scatter plot either is or is not related and in which way. Okay. And like I said earlier, this is all going to lead up to what we've been doing, which is writing linear equations. And we'll start with that on Wednesday. But today and tomorrow, we're just going to talk about scatter plots in general. Okay, so let's start off by talking about and learning what a scatter plot is. So a lot of times in the real world, when you take data, you collect data. Say you do a survey of something, and you're comparing two pieces of information, and you want to see how they're connected, how they're related. The best way is to put it on a graph. And a lot of times when you make a graph, what's going to seem like it doesn't make sense, like the data is all just scattered, and that's why we call it a scatter plot. So as you can see, we have an example of a scatter plot here, and we're going to learn what it is and how to read and interpret it. So let's begin. So a scatter plot, and what it is, it's a graph that uses points to display numerical data. So this first word here, it's use points to display numerical data. Let's write the word numerical in there. So it's numerical data with two variables. So the key here is that it's with two variables. Or sometimes we call this bivariate, like a bicycle meaning two wheels. This is bivariate meaning two variables. Bivariate. Bivariate data. Okay. So scatter plots can help determine if one variable has an effect on the other, or if there are overall trends, patterns, or, and this is a key word, associations. Between the variables. Another word that kind of gets used along with association, it's a synonym for it, is correlation. In the Delta Math assignment we're going to use, they use both the word association or correlation. And really what we're looking there is, does one thing affect the other? Are they connected in some way? Whatever we're measuring on one axis, is it connected or related to the other? Okay. Any questions so far? Okay, so the words we have so far are numerical, bivariate, bivariate, association, or correlation. Okay, so let's look at a scatter plot to see what this is all about. So we have this situation. Let me zoom in a little more so you can really look at what we're understand what we're looking at. Okay. Okay, so we have Zara surveyed shoppers at a mall to see how many items they'd purchased and the total amount of money they'd spent at the mall. She used the data to create a scatter plot shown. So here's the scatter plot that she made. So as you can see, on the x-axis, the horizontal axis, she's measuring the number of items they purchased. And then on the y-axis, the vertical one, it's the total amount of money they spent. Okay? So the first question, hopefully, is pretty easy. How can we figure out how many shoppers Zara surveyed? So I want you to think about that. Just by looking at the graph, we can figure out how many people she surveyed and asked questions to. Look at the dots, count them. How many dots are there? More than 10. I believe there's 16. So there's 16 dots, which is the number of people. Okay. So let's just take a look at this. Let's analyze this a little bit. So as you can see, she had several people. So this person bought one item, but it was almost $80, right? And this other person bought 3 items, and it was like almost $140. But here you have one person who bought 8 items, and it was like $150. And here a person that bought 10 items, and it was just about $200 that they spent. So does the number of items purchased seem to have an effect on the amount of money a shopper spent? What do you think? In other words, does the number of items you buy tell us anything about how much they spent? I would say yeah. I would agree with Jaden. Yes. So let's kind of figure it out. So let's finish off the sentence. The more items you purchase at the mall, how does it affect the amount you spend at the mall? The more money you spend. The more items you buy, the more money you spend. I mean, that makes sense. And that's in general, right? Like you might have, like this person bought 3 items and it was like, $140. That's kind of a little more than the trend, but in general, that's how it goes. And if you go and you buy a bunch of little things that aren't too expensive, then you wouldn't have spent as much as someone that might have just spent something for an iPhone or something, a big ticket item as they call them. But in general, that's how it goes. All right, so this describes a type of association, guys. An association. So we're going to use the table below to define 3 types of association. So if you have a highlighter, go ahead and highlight this because there's 3 possible types of association. And here they are. It's either positive association, negative association, or no association. Those are the 3 types of association. Okay? So the thing I like about these scatter plots is they're very visual. Okay? So let's look at the first one, a positive association. Okay? So follow along with me. Do you see how the points here tend to go uphill? Whenever you have a positive association, the points in general will go upwards, uphill like that. Same thing with a negative association. The points tend to go downhill. Okay? And now, what do you notice about this scatter plot with no association? Yeah, they're just kind of spread out, right? They're just kind of spread out. All right. So let's get into some details here. Let's start with positive association. So in a positive association, as one variable increases, the other variable also increases. So over here, we're going to write the word increases. The variables change in the same direction. So we're going to write the word same here. So make sure you write that down. Write down the word same. Okay. Now, notice I say in general, this is what happens, right? So as x increases, y increases. See, the points tend to go just uphill. One is going up, the other one's going up. Now, say I had something, I don't know, a point down here. Say I had this, go ahead and draw a point in right there. Is that point following the general trend? No. And that's going to happen sometimes. When a point isn't following the rest of the points, it's doing its own thing, right? It's listening to its own heart, maybe. This is called an outlier. Outlier. It lies outside the rest of the points. Okay? So if you have that one loner point that's all by its lonesome, it's okay. It's going to happen. For whatever reason, this is the real world. Not everything's perfect. And these things will happen. It's called an outlier. Okay? All right. So let's take a look at a negative association. As one variable increases, the other variable decreases. Exactamente. It decreases. So the variables change in opposite directions. We're going to write the word opposite here. Opposite directions. So in general, as x increases, y decreases. But you may have something, an outlier here may live over here. X is a very big number, and y is also a big number. That's not typically what's going to happen. And so this would be an outlier. It's off on its own. It's doing its own thing. Again, it's not part of the general trend of the points. Okay, so a no association, kind of the points are just really everywhere. There's no real pattern. So in no association, the change in one variable has no effect on the second variable. Okay, no effect on the second variable. So we're going to try this now. We have three situations. We're going to describe the type of association expected to see between the following variables. Okay? So we're going to have either a positive, negative, or no association with these three situations. So let's see if we can't figure them out. So let's look at this first situation. Number one, the number of shoes a person owns and the number of states they visited. You think there's a connection there? Doesn't seem to be, right? You could have someone that has a lot of shoes, right? But maybe they've only been to one or two states. Or you could have someone that has a lot of shoes that's been everywhere or been to a lot of states. So I would say that one is no association. So if we were to graph these, if we surveyed a bunch of people, asked them, how many shoes do you own? What states have you visited? The graph would look something like this one, the no association. Okay. Let's look at number two. Number two, the size in ounces of a steak and the cost of the steak. Okay, so would that be Positive, negative, or no association? What do you think? What do you think? Positive, yeah. The bigger the steak, what does that tell us about the cost of the steak? Yeah. So that's definitely positive. That's a positive association. Okay. And the last one, the number of days since watering a plant and the moisture level of the soil. So the number of days since watering a plant. So say you spent 10 days without watering your plant. What are you going to know about the moisture level in the of that soil? It dries up, right? That would be a negative association. The more time you spend from watering your plant, the lower the moisture level goes. So that would be a negative association. Okay, so today's assignment will be very much like this stuff. We won't be looking at formulas or calculating equations, but we're going to look at, like, it's called qualitative stuff. Not quantitative, it's qualitative. This type of thinking. Okay? All right, you guys ready to go on to the next page? Let's do it. Okay. All right, so the other thing we can do is describe the strength and the type of association, whether it's linear or nonlinear. And so we're going to look at those next. Okay? So let's talk about the strength of the association, first of all. And this is actually pretty easy. It's all visual stuff. If the data points are close together, the association is strong. We call that a strong association. The closer together the points are. And if the data points are widely spread, the association is what we call weak. So we're going to call these A and B. So one of them is weak, one of them is strong. How would you describe A? Strong. Yeah, especially compared to this one, compared to B. So this is a strong association. Okay, and when you have a strong association, that means the connection between whatever you're measuring on X and Y, there's a strong connection there. Okay, whereas here, this one is, they're a little more spread out. This is a weak association. Meaning, yes, the two things are related. Whatever X is measuring, whatever Y is measuring, they're related, but not as strongly. Okay, so that's strong and weak associations. The other thing is you can have linear or nonlinear associations. Okay, so if a straight line can be drawn to show the overall trend of a scatter plot, the association can be described as linear. So look at this first graph. If you look at this first graph, okay, on this graph, do you notice that I can draw kind of a line overlapping the middle and it kind of describes it? We're going to be doing a lot of this starting Wednesday, actually. If I draw that line, do you notice it kind of covers the whole thing there? Mm-hmm. Okay, that's known as a linear graph. So this one is definitely linear. Okay, well, look at this other graph. We can't really say there's no association. We can't say this is a no association graph. It looks like there's an association, but does that association, does that connection between the points, does it Does it make a line? Not a straight line, right? It makes more of a curve. So if the association makes kind of like a curve, then there's an association, there's a connection there, but it's nonlinear. And if you get into in high school, if you decide to take a statistics class, maybe you'll talk more about nonlinear associations. But that's after you've taken algebra 1 and algebra 2 and all that stuff, and then you can work with the math involved for that later on. But we're going to mainly deal with linear associations, okay? Okay, so you can have linear or nonlinear. And for us, all we need to do is recognize which one is which. Okay, so speaking of that, here's our next task. We're going to look at these scatter plots, A, B, C, and D, and we're going to answer some questions, 4 questions related to these scatter plots. And hopefully you find them pretty easy. So here we go. So take a look at these graphs. Let's see what we got. It says, which scatter plots, I'm looking at number 4, which scatter plots show linear association? So which of the scatter plots have a linear association? Definitely B, right? And C. One's positive and one's negative. Okay, so let's start with that. B and C. Okay, let's move on to number 5. Which scatter plots show a nonlinear association? A and B, right? Look at this A. There's a connection here. There's some sort of association, but it doesn't form a line. Same thing with D. Okay, so we'll say A and D. Okay, moving right along. Number 6. Which scatter plot shows the weakest association? Which one? Yeah, I wouldn't say it's very strong, but I think C is a little weaker. I think the points around C are just a little more spread out. Yeah, definitely if we're going in order, D would be a little bit stronger than C. So let's go with C there. Okay, I think this next one will be pretty obvious though. Which scatter plot has the strongest association? A, yeah, they're most tightly packed for A. Okay. All right. So the last thing we're going to do is, I like that purple. Gotta use that purple marker more. So for A through 10, we're going to draw a line from each scatter plot to the best description of the association and then to the variables it would most likely represent. Not all choices will be used. Okay, so let's take a look at B. And these are our choices: positive linear, positive nonlinear, negative linear, negative nonlinear, or no association. Number 8. Which one would you say that is? Yeah, that's a no. It's kind of just spread out. There's no obvious connection. So let's draw a line this way like that, connecting those. So that's a no association. Let's look at the next one. Number 9, what would this be? Positive and linear. It's definitely going uphill, and it's most certainly linear. Let's go with positive and linear. Okay, so this one would be connected this way. Okay. And number 10. Yeah, this one's negative, definitely going downhill, and it looks to be forming a line. So negative and linear. Okay, so now these are our choices. Positive linear, um, negative linear, and no association. Okay, so let's look at these three situations, see which one is which. Okay, you guys ready? Let's look at the first one. The temperature outside and the total gallons of gas sold at a gas station. Is there a connection between those two things? The temperature and the amount of gas sold? So which one of these would be the best, most? Actually, yeah. No association. Yeah, there's no connection at all. That would be a no association. Okay. So we connected those. Next, the altitude of a hiker and the total oxygen level in the air. So think about this. What happens to the level of oxygen the higher up? You it gets thinner, right? So as the height increases, the oxygen level, is that positive or negative? That's negative. So we'll connect these two together. And the last one presumably should be positive. Let's see if that's true. The size of a home and the cost of monthly utilities for the home. So usually you measure the size of a home in square feet. So as the square feet of the home increases, what happens to the cost of price goes up, right? That would be a positive. As one increases, the other increases. There you are. Okay. So in a little bit, I will lend you glue sticks to put this in your notes. But right now, open up your Chromebooks, though. Open up your Chromebooks and please go to Delta Math. I'll show you. We have some examples we're going to go through together on Delta. Okay? And if you play your cards right, I'd say in the other two classes, more than half the classes finished this assignment, the homework in class. So